Hey everyone, in this video we're going to talk about creating tables to find points on a graph. So in the first day of the unit we talked about this coordinate plane, the quadrants, what a coordinate pair was, what the point x comma y was, and where to plot it on the coordinate plane. Then we talked about a point being on the graph of an equation if it makes the equation true. And we talked about the graph of an equation being made up of all of the points that make an equation true. So today we're going to connect those ideas and use tables to get points that are on the graph of an equation. So in this first example, we need to graph the equation y equals negative 2x plus 5. So there's a table here in which we are given x values, right? We have x value of negative 2 and x value of negative 1, of 0, 1, and 2. We are going to plug those x values one at a time into the equation and evaluate to determine the value of y, and then that will give us a point that's on the graph. We're plugging in an x value, we're evaluating to get a y value, and together that gives us a point on the graph. So the equation says y equals negative 2x, but instead of x, I'm going to plug in this negative 2 plus 5. I know that negative 2 times negative 2 is a positive 4 plus 5, and 4 plus 5 is equal to 9. So the point negative 2, 9 is on the graph of this equation. When x is negative 2, y is equal to 9. So I will plot that point on the graph. So negative 2 means going to left from the origin, and a y coordinate of 9 means go up 9. So I'll just show that. So we went left 2 from the origin and up 9 from there. So this is that first point, negative 2 comma 9. Now I'm just going to repeat that process plugging in the other x values in the table. So y equals negative 2 times, I'm going to plug in this x value of negative 1 plus 5. I know negative 2 times negative 1 is positive 2 plus 5. 2 plus 5 is 7. So when x equals negative 1, y equals 7. And the point negative 1, 7 is on the graph. That would be the point right here. I'm going to just repeat this process with the other x values. Y equals negative 2 times this x value of 0 plus 5. I know negative 2 times 0 is 0 plus 5. 0 plus 5 is 5. So when the x value is 0, the y value is 5. And then I will plot that point on the graph. 0, 5 will be right here. Okay, so these are the 3 points that I have so far. I'm going to get 2 more points by plugging in 1 for x. Negative 2 times 1 is negative 2, plus 5 is 3. So the point 1, 3 is on the graph. 1, 1, 2, 3. Notice these points are all falling in a line. Okay, the last point I'm going to get is when I plug in positive 2 for x. Negative 2 times positive 2 is negative 4 plus 5. Negative 4 plus 5 is positive 1. So when I plugged in 2, I got 1. And I will plot that on the graph, 2, 1. And then we're just going to connect those points with a line. So this line represents the graph of this equation. Okay, looking at another example, we're going to follow the same process. This time we have the equation y equals 7 minus 3x. I'm going to plug in x values of -2, -1, 0, 1, and 2 into this equation. So y is equal to 7 minus 3x, which is -2. 7 minus 3 times -2 is -6. When I subtract a negative, I'm really adding. 7 plus 6 is 13. So that is the point -2, 13. I'm looking at the graph. That's actually a little bit off the grid here. -2, positive 13. It's about right here. Okay, we're going to just repeat that process with these other x values. Y equals 7 minus 3 times -1. 7 minus 3 times -1 is -3. When I subtract a negative, I add. 7 plus 3 is 10. So the point is -1, 10. And I will plot that is right here on the graph. Left 1 from the origin and up 10. For the next point, 7 minus 3 times 0. 7 minus 3 times 0 is 0. And 7 minus 0 is 7. So this is the point 0, 7. And when I plot that, I'm not moving left or right from the origin at all. I'm just going up 7. For the next point, y equals 7 minus 3 times 1. 7 minus 3 times 1 is 3, and 7 minus 3 is 4. So this is the point 1, 4. And when I plot that, it lands right here on the graph. And the last one, y equals 7 minus 3 times 2. 7 minus 3 times 2 is 6, and 7 minus 6 is 1. So when x is 2, y is 1, that point is right here on the grid. So again, I will make a line that goes through these points, doing your best to make that a straight line, and going through all of those points. If you have a ruler, that could be helpful. Or even better, if you're in Kami, when you make the line, it should be better than drawing it by hand. All right, in these next two examples, the graphs of these equations are not going to be a line like in problem 1 and problem 2. So if you notice, this first equation has the absolute value function in it, right? So these lines, this means absolute value. Just a reminder, when you take the absolute value of a number, the answer is always positive. So we're talking about how far that number is away from 0. So if we're talking about the absolute value of 3, let's say, and we think about a number line, 0, 1, 2, 3. How far is this away from 0? It is 3 units from 0. So the absolute value of 3 is 3. If we were looking at the absolute value of -5, let's say, -5, that's here. How far away from 0 is that? That is 5 units away from 0. So the absolute value of -5 is +5. But just like in the previous examples, we are going to plug in x values to the equation and evaluate to get y values. So y is equal to the absolute value of x, which in this example is 1, minus 2 plus 3. 1 minus 2 is -1, so absolute value of -1 plus 3. And the absolute value of -1 is 1, because that is 1 unit away from 0, plus 3. 1 plus 3 is equal to 4. So when we plugged in 1 for x, we got 4 for y. And when we plot that, it is right here. Okay, we'll follow the same process, plugging in 2 for x. Y is equal to the absolute value of 2 minus 2 plus 3. 2 minus 2 is 0, so absolute value of 0 plus 3. The absolute value of 0 is 0, plus 3 is 3. So when we plugged in 2, we got a y value of 3. And when we plot that on the graph, it is right here. Plugging in 3, y equals absolute value of 3 minus 2 plus 3. 3 minus 2 is 1 plus 3. Absolute value of 1 is 1 plus 3 is 4. So when we plugged in 3, we got a y value of 4. Plotting that, 3, 4 is right here. Notice already we don't have a line. We have like a little bit of a smiley face with those 2 points, 2 eyes and a nose maybe. Plugging in that last x value, we have y equals the absolute value of 4 minus 2 plus 3. 4 minus 2 is 2, so absolute value of 2 plus 3. The absolute value of 2 is 2, plus 3 is 5. So when we plug in 4, we get a y value of 5, and when we plot that point, 4, 5 is right here. Okay, so this looks like a little bit of a check mark. This line continues this way, and this part goes this way, and this actually is called a V-shaped graph. Okay, so an absolute value function will always have a shape that looks like a V. All right, this last example has this exponent of 2, okay, has an x squared. That's called a quadratic. We'll talk about that later in the year or maybe next year. But we're just plugging in x values to the equation and evaluating, okay? So we're going to plug in these x values. Now we have to notice in the equation, though, that x appears twice. So we want to make sure that we plug those x values in both times that x appears in the equation. So y is equal to x, which is negative 3, squared, plus 2 times x, which is negative 3, minus 3, right? So I'm taking this negative 3 here, and I'm plugging it here where I see x and here where I see x. Now I know negative 3 squared is positive 9, right? A negative times a negative is a positive. Plus 2 times negative 3, that's negative 6. Then minus 3. And 9 plus negative 6 is 3. And 3 minus 3 is 0. So when we plug in negative 3 for x, we got a y coordinate of 0. On the graph, that is right here. Okay, just going to follow the same process. Y is equal to x, which is negative 2, squared, plus 2x, which is negative 2, minus 3. Negative 2 squared is 4, right? Negative 2 times negative 2, that becomes a positive 4. Plus 2 times negative 2 is negative 4, minus 3. 4 plus negative 4 is 0, and 0 minus 3 is negative 3. So when x is negative 2, y is negative 3. And that point is right here on the graph. Plugging in negative 1 for x. Y equals negative 1 squared plus 2 times negative 1 minus 3. Negative 1 squared is positive 1. 2 times negative 1 is negative 2 minus 3. 1 plus negative 2, that's negative 1. Minus 3 is negative 4. So when we plugged in negative 1, we got a y value of -4. -1, -4 would be right here. Plugging in 0 for x, y equals 0 squared plus 2 times 0 minus 3. 0 squared, 0 times 0 is 0. 2 times 0 is 0. Minus 3. 0 plus 0 is 0. Minus 3 is -3. So this is the point 0, -3. Plotted right here. So that graph is starting to come back up again. When we plug in 1 for x, y equals 1 squared plus 2 times 1 minus 3. 1 squared is 1. 2 times 1 is 2 minus 3. 1 plus 2 is 3, and 3 minus 3 is 0. So when we plugged in 1 for x, we got 0 for y. And when we plot that, that is right here. And last but not least, our last coordinate when x is 2. So plugging in 2 for x, 2 times 2 minus 3. 2 squared is 4, plus 2 times 2 is 4, minus 3. 4 plus 4 is 8, and 8 minus 3 is 5. So when we plugged in 2 for x, we got 5 for y, and we will plot that right here. That is the point 25. So we're going to connect these points with a smooth curve. Okay, this isn't really a V shape anymore. It's a U shape. And a fancy term for that is a parabola. And if you don't remember that, that's okay. You don't really need to know that. But anytime you have an x squared equation, your graph should be U-shaped. Just like every time you have an absolute value equation, your graph would be in the shape of a V. All right, so to summarize, we're going to plug x values into equations to evaluate and find the y value. And then putting the x value that we plugged in together with the y value that we got out gives us a point that is on the graph. Now you go try some practice. Have a good day.